Let's look at the question from 2014 February paper 2, question 9. So basically this question is based on trigonometric graphs, grade 12. Okay, the graph of f of x equal to cos x minus 45. So this is the graph of cos that has been shifted 45 degrees to the right. So which means is this graph? Because normally the graph of cos will start here and go down. This is shifted 45 degrees to the right. So that's the graph of cos. And then the other graph that's given is g of x, which is negative 2 sine x. Basically, it's the sine graph that is being reflected. Normally, the sine graph will go something like that and something like that. But this one has been reflected on the x-axis. So let's highlight that graph again. They said here those two graphs are drawn below from x equal to negative 180 to positive 180. And then we are told that t is what? Is the x-intercept of f, as indicated on the diagram. Okay, let's look at the questions. The first question is, show that cos x minus 45 degrees equal to negative 2 sine x can be written as 10x equal to 0.2612. Basically here, this is the point of intersection. They want us to work out the the point of intersection, the x of the point of intersection. So what you're going to do here, we have cos x minus 45 is equal to negative 2 sine x. You cannot divide by cos both sides to form a 10 because the angles are different. This angle is x minus 45, this is just x. And you can't use the fact that sine x is equal to cos 90 minus x because you have a coefficient here. So here you have no choice but to expand this using compound angles. So let's expand the cos x minus 45. So it's going to be cos x cos 45 now become plus sine x sine 45 is equal to negative 2 sine x. Remember that cos 45 is square root of 2 over 2 cos x, and plus sine 45 is square root of 2 over 2 sine x equal to negative 2 sine x. So what I'm going to do, I'm going to transpose the square root of 2 over 2 sine x. So I have square root of 2 over 2 cos x is equal to negative 2 sine x minus square root of 2 over 2 sine x. Can add the like terms, but here I prefer to factorize. So square root of 2 over 2 cos x is equal to, I will take sine x as a common factor. And then I'm left with minus 2 minus square root of 2 over 2. Then what I'm going to do next, I'll divide by cos both sides. So divide by cos x cos x. So I have square root of 2 over 2 is equal to sine over cos, that will be 10 x, and then divide it, and then we multiply it by square root of 2 minus square root of 2 over 2. Then what I'm going to do, I'll just divide by this term both sides, which would be divided by minus 2 minus square root of 2 over 2. Here I'll put a normal division sign, minus 2 minus square root of 2 over 2. And then that will cancel, Then on the right hand side, you're left with 10. Left hand side, if you simplify this with a calculator, you will get 10x is equal to negative 0.2612. So we have proved that. Okay, so next question, solve the equation for x between negative 180 to positive 180. And remember, we've already proved that this equation is equal to that. So I'm just going to write 10x is equal to negative 0.2612. Then I get a reference angle, which you're going to say shift cos, but you don't put the negative on the calculator. The negative is just telling us the quadrant. Okay, so here I will say shift 10 0.2612, and then that will give me 14.64 degrees. Okay, and remember this negative is telling me which quadrants am I working on. We know that 10 is positive in quadrant 1 and 3, but it's negative in quadrant number 2 and quadrant number 4. So for quadrant 2, I will say x is equal to 180 minus 14.64 plus k. Remember, for 10 period is 180. So it's k 180 with k element of integers. Then again, you put that on the calculator. 180 minus 14.64. That gives me 165.36 plus k 180 degrees. And then that's that for quadrant 2. And for quadrant 4, remember quadrant 4 is 360 minus. So it's 360 minus 14.64 plus k 180 with k element of integers. Okay, so 360 minus 14.64, that will give us 345.36 plus k 180 degrees. So those are the two equations. So we have this equation and that equation. So now to get the solution, what you're going to do, you're going to substitute the integer values of k. Negative, for example, you can say negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. Once you've done that, there are only two solutions. The first one is negative 14.64. The second one is 165.36. Okay, so we can put that on the graph to make our life easy, which means that we have this point of intersection, we have that point of intersection. So the value of x there at this point is negative 14.64. And then that's another point of intersection. We know the value of x at that point as 165.36 degrees. Okay, we move on to the next question. The question is, write down the coordinates of point T. So what you're going to do here, T, you can see that this is the x-intercept of the graph of f. So what you're going to do, you're going to put your graph of f on the calculator. Means this graph on the calculator with a start of negative 180 and this 180, and then use the step of 45. So you can see that the value of x that you're going to get, that will give you y of 0, which is the x-intercept, is what? Is 135. So the coordinates of t is 135 and 0. So there t is 135 is to 0. Then the next question, write down the interval for which f of x is greater than g of x. So you're looking for the values of x where the f graph is above the g graph. So let's check. F graph is the purple graph, and then g graph is the blue graph. So for which values of x is the purple graph above the blue graph? So you can clearly see that is from this value of x all the way up to that value of x, which means it's from negative 14.64 up to 165.36. So we're going to write our solution. X element of is going to be a square bracket because it's greater than or equal to. So that is negative 14.64 all the way up to 165.36 degrees. Then the next question now. Write down the interval for which both f and g are strictly increasing. Okay, so let's go to our graph. So you can see that this graph, let's start with the graph of g. There it is increasing as you are moving from left to right. And then there it's decreasing, and then here it's increasing again. So that's the graph of g. Then for the graph of f, for this point, it's decreasing. Then until you get to this, which is the turning point, all the way up to here, it's increasing. Then there it is decreasing. Now, what are we looking for here? We are looking for the values of x where those two graphs are both increasing. Otherwise, they're increasing at the same time. So, we need to know the turning points. In particular, since the two graphs are both increasing from this point, which is the turning point, is the minimum of the f graph, all the way up until we get to this point. So basically, it's just this interval from this x up to that x. So let's work out the values of those x's. So if you put the graph of f on the calculator, you can work out that the minimum is negative 135. So the minimum here, the value of x here is negative 135. Then if you put the graph on the blue graph on the calculator, the graph of g, this point is the maximum, and the maximum there will be negative 90. So the maximum, this is the minimum, that's the 135. The maximum here will be negative 90. Remember, I said to you, the two graphs are both increasing in this portion from negative 135 up to negative 90. So let's write the solution. So the two graphs, remember, strictly increasing. So we're going to say it's from negative 135, so it's a round bracket because it's strictly increasing. Negative 135 up to negative 90. Okay. Then the last question. The graph of h is obtained when the graph of f is shifted 45 degrees to the right. Write down the equation of the graph of h in simplest form. We know that the graph of f of x is equal to what? Is equal to cos x minus 45. So it's cos x minus 45 degrees. Now, in order to get the graph of h, we have to take this graph and shift it 45 degrees to the right. And remember, if you are shifting to the right, you will have to subtract 45. If it was left, you will add 45. So h of x is going to be cos x minus 45, and then, which is this. And then we subtract 45 because this is going to the right. So minus another 45. And then that will be cos x minus 45, and minus 45 is 90. Then we want to write this in standard form. It's going to be cos, remember you take out a negative, then you write 90 minus x. Then you get rid of this negative using the fact that cos negative theta is equal to positive cos theta. If it was sine or tan, then that negative was going to come here. So now negative is gone. It's cos 90 minus x. And cos 90 minus x from reduction formula is sine x. That's the end of that question.